Okay, I just wanted to go over one or two problems that we had gone over in class, just so you can see them work out again if you didn't get a good chance in your notes or whatever. So first off, find the perpendicular distance from a point P sub 0 equal to the point 135 to the plane 2x plus 3y minus 5z equals 0. So, just to draw a rough sketch of what's going on, I have some arbitrary plane right here. I don't really care where it is in space right now. And I have some point P sub 0, which I'll say is right here. I have that plane, I have that point. I want to find the perpendicular distance from that point to the plane. Which means, if I just go down here, I need to find this point on the plane. I guess maybe we can call it P or P sub 1. We'll just go with P here. And I need to find that distance from there to there. But if you think about it again, from maybe a pre-calc, before calc 3 perspective, really the perpendicular distance is that distance, which means if I can find this point, then I'm really just finding the distance between the 2 points. We have the three-dimensional distance formula, so that's not a problem. So I have this point. Once I can find that point, I'm good. And the question is, how do I go about finding it? Well, let's see. First off, this point and this point would have to be on the same line. Like if I actually let this line continue, I don't want to draw on the board, but going through the point here. So if I can find the equation of that line connecting the 2 points, then I can really just pick that point on the line. So how do I get the points on the line? Well, I know I have parametric equations for a line. Let's see. I had the equations were, in your book's notation, x sub 0 plus at, y was equal to y sub 0 plus bt, z was equal to z sub 0 plus ct. And that generates all the points on the line. X sub 0, y sub 0, z sub 0 was a point on the line. I have that right here. ABC was a directional vector for the line that you have. But in this case, this line that I care about is perpendicular to the plane because I'm looking for the perpendicular distance. But a vector that's perpendicular to that plane is the normal vector of that plane, which we know I can pull right off of that equation. 2, 3, negative 5. But now, this normal vector is perpendicular to the plane, which means it's a direction vector for my line, which is perpendicular to the plane. So now I have an ABC. So now I can plug in here, and I get that x is equal to x sub 0, which is 1 plus 2t. Y is equal to 3 plus 3t. And z is equal to 5 minus 5t. Now, I need a drink of water, but I don't have any. Okay, now I have parametric equations for the line that will generate every point on that line. We said I'm looking for this particular point, which is the point on the plane. So, if this generates all points on the line, and this is my plane right here, in order to guarantee that whatever arbitrary x, y, z point I have is on that plane, I just substitute in. So, I get, I'll do it over here in green, 2 times the x, which is x sub 0 plus at, or in this case, 1 plus 2t, plus 3 times y, which is 3 plus 3t, minus 5 times z, which is 5 minus 5t. All of that equals 0. Now just do the algebra and solve it. So really quickly, 2 times 1 is 2, plus 4t, plus 9 plus 9t, minus 25 plus 25t. let's see, 2 plus 9 is 11 minus 25 is negative 14. Add it to the other side and you get positive 14. 14 plus 90 is 13, plus 25 is 38. So 38t equals 14, so t equals 14 over 38. So t is 7 over 19. And that's exactly what I got in my notes, so that makes me happy. And now what that means is, if I take this t and plug it into these parametric equations, the resulting x, y, z point I get will be a point on that plane. It'll be my p right there. So now, just plug in, and now I'm just going to get rid of that part of my plane so I have more room to write. And I get x is equal to 1 plus 2 times, whatever it was, I just erased it, 7/19. Y equals 3 plus 3 times 7/19. Z is equal to 5 minus 5 times 7/19. And solve those out. Let's see, that would be 19 over 19, so it's 19 plus 7 times 2, 14 over 19. This is, let's see, over 19, 3 times 19 is 57. So that's 57 plus 3 times 7, which is 21 over 19. 5 times 19 is 95. So that's 95 minus 5 times 7, 35 over 19. 19 plus 14 is 33/19. 57 plus 21 is 78/19. 95 minus 35 is 60/19. And now I have my p right there. And now the part that I'm not going to do in this video, but I'll kind of leave for you to do. I now have this point p, x, y, z. I have the point p sub 0. I want to find the distance between them, so I can just use the distance formula. The distance is equal to the square root of the change in the x's, 1 minus 33 over 19 squared, plus the change in the y's, 3 minus 78 over 19 squared, plus the change in the z's, 5 minus 60 over 19 squared. All of that square rooted. That's a calculator thing, so your people can go into your calculator and get the answer and be good. And one thing I would actually point out, as I pointed out in class, once you get that answer, you should be able to tell if it's logical or reasonable, meaning the t value that I found to put that point on that plane was t equal to 7/19, which is really small. Which means when I plugged it in here, if this was my original point right here, that t is not going to move it very much because t is so small. Here, with those small coefficients, it won't move much at all. Here, it'll move a little bit because of the 5 coefficient, but it means if I'm not moving much to get from p sub 0 to p, then the distance between them should be relatively small. So when you do the calculation out, make sure the answer you get is relatively small. I want to say from class it's right around 4.5 or so, but it's around 4 point something. Don't quote me on that. I will make another video probably right now because it takes a while to work through the solution of another problem. So I'll just stop this one right here for this.